Hi all, today we are going to discuss nucleophilic substitution reaction. So this is a substitution reaction where a nucleophile will be attacking the alkyl halide. In this case, the halogens will be the leaving group. So nucleophilic substitution reaction takes place in two forms, that is SN1 and SN2. That means nucleophilic reactions are of two types. Nucleophilic substitution unimolecular and nucleophilic substitution bimolecular. So what is this unimolecular and bimolecular, and everything related to this mechanism we are going to discuss. Also we are going to discuss SN1 prime and SN2. Also SN neighboring group participation reaction. So let's start. So first we are going to discuss SN1 reaction. In SN1 reaction, the alkyl halide, first what will be taking place? Slow reaction will be taking place in which the halo group will be removed. The halo group will be removed and a carbocation is formed here, as you can see. And this is the slow step. And once the carbocation is formed, the nucleophile will be coming and attacking the carbocation and the product will be formed. In this case, the reaction takes place in two steps. That is, first step is the formation of carbocation, and that is the slowest step, in which the leaving group will be leaving, and the leaving group here is bromine and a carbocation is formed. And in the second step, the nucleophile, here nucleophile is OH negative. So this is taking this carbocation and the product is formed. So this is unimolecular reaction. Why? Because in this case the rate determining step, that is the slowest step, is the first, where step is the first step, which is the slowest step. And you can see here rate is equal to K, that is the rate constant, and it depends upon the concentration of the reactant. So next we are going to discuss SN2 reaction. In SN2, the attack of the nucleophile and the leaving of the leaving group takes place simultaneously, and that is the slowest step. It is one step reaction, and the nucleophile is attacking the carbon atom from the back side, because already here the leaving group is already present here. Both attacking and leaving takes place simultaneously. So in this case, rate depends upon concentration of both the nucleophile and the reactant which we have taken, alkyl halide. So in this case, you can say this is a bimolecular reaction. So in this case, order of the reaction is 2. In SN1 prime, it is mainly taking place for allylic bromine. Allylic bromines means in the second position you can see a double bond. So this is the first position and this is the second position. So in the second position, if there is double bond, it is called allylic. Okay, this is an allylic bromine. And in first step, slowest step, what will be taking place, as it is S1, so it will be taking place in two steps. First, that is carbocation is formed, the bromine group will be leaving, and the carbocation is formed in this particular position. In the next case, rearrangement takes place. That means this double bond will be coming and forming here bond. So rearrangement is taking place and this carbocation is formed. That means this carbon becomes electron deficient, right? So the positive charge is formed here. So after the formation of the carbocation, the respective products are formed. The main difference between SN1 prime and SN1 is that in SN1 no rearrangement takes place, but in SN1 prime rearrangement takes place, and then the nucleophile will be attacking the electron deficient carbon atom. So like that of SN1, this is also first step reaction, that is now first step is a rate determining step and the order of the reaction is 1. Next is SN2 prime. In SN2 prime also, like SN1 prime, rearrangement takes place. If it is SN2 normal, then this type of reaction will be taking place, that is no rearrangement, the chlorine group is leaving this particular position. Chlorine group is leaving and the OH group from KOH is coming and attacking the this carbon position, and ultimately this intermediate is formed, normal intermediate, that is SN2. But if rearrangement takes place, that means this double bond is shifted here, then you can see the OH group will be attacking this carbon because it will be having electron deficiency. So two products are formed. So again in SN2 the rearrangement takes place and the product which is formed, we call that as SN2 prime. So this reaction takes place in one step. As we know, for SN2 the reaction takes place in one step. So this is the rate of the reaction. So next one we are going to discuss is SNngp. Ngp means neighboring group participation, and this will be taking place when nucleophile is present at the third, fifth or the sixth position from the leaving group. So in this case you can see chlorine. I have taken an example. So see here, first I am going to discuss the reaction, then I am going through the mechanism. So in this case, in this reaction, this is the leaving group and one more nucleophile is present in which position? 1, 2, 3. Third position, one more nucleophile is present in that carbon chain itself, isn't it? And in order to distinguish between this and this carbon, I have written here 14 carbon, that is 14 carbon isotope. Now you can see the two types of product is formed. One is normal, this group is removed, and the attacking group, that is OH, which we have added as potassium hydroxide, is coming and attacking this particular carbon atom, and the product from is this is very normal, right? But in case of this product, you can see this carbon atom is shifted here. So how this takes place we are going to discuss. So this is our normal product that is possible. Yes, this chlorine is removed and OH is coming and attacking here, but this carbon, in order to form this particular product, this carbon should be shifting here, right? As you can see, the 14 carbon is shifted with the sulfur. So let us discuss the mechanism of this. So see here mechanism. So in the chlorine group will be leaving, and the chlorine group is leaving, and the lone pair present in sulfur is attacking the 14 carbon atom, and ultimately this is coming down and a cyclic intermediate is formed. As you can see, sulfur is having positive charge and cyclic intermediate is formed, and from this cyclic intermediate the OH can attack by two probability, that is the OH is directly attacking the 14 carbon, and this bond is breaking between 14 carbon and sulfur, that is the normal product which you are going to get. And in the second case, the OH group is attacking the other carbon. When the OH group is attacking this particular carbon, that is normal 12 carbon, so the normal 12 carbon and sulfur bond is broken here. Yes, this particular bond is broken, and ultimately this product is formed. And you can see here, so if you open up this bond, you can see the product is formed like this. So this is the mechanism of SNngp. So NGP is neighboring group participation. Which one is the neighboring group? This sulfur is the neighboring group which is participating in this particular reaction. So I hope you have understood this video. Let me know in the comment section if there is any doubt, and if you like this video, please do subscribe my channel. Thank you for watching.